Okay, so this is going to be section 11.7. It is the surface area of a sphere. Before we move on here, just a quick little reminder on kind of what surface area and volume, how those are different. So when we're talking about our sphere, right, the surface area is imagining you were painting that whole thing. How much paint would you need? Where the volume is going to be how much would it take to fill up the inside of that sphere. Surface area is measured in square units, so square meters, square centimeters, square inches, that kind of thing, because it is area, where volume is measured in cubic units, so cubic centimeters, cubic meters, cubic inches, because you're imagining how many little tiny cubes. That's the picture I want in your head. How many little tiny cubes would it fill up? For a surface area, you're imagining how many squares would it take to cover that surface. So keep those in mind, what the difference of those are when you're talking about these questions. So if you were gone and you're just watching this video, you missed out on the oranges. So here's what we did. We took an orange, we traced it on the paper 4 times to get 4 circles that had the exact same radius as our orange. We peeled the oranges and we tore them up into little pieces, the peels, and placed them on those circles. Each of those circles had an area of pi r squared, where the r is the same r as the sphere. And we noticed that the orange pieces filled up 4 circles. And so the surface area of the orange was 4 times pi r squared, just 4 times the area of the circle. And so that is our formula for a sphere. Make sure you have that written down in your note sheet. A couple of really big things here. This is area. So we have r squared because in area we use square units, right? So when we plug in something like 4 times pi times 6 centimeters squared, we're going to get, what is that? 36 times 4 would be 108 pi centimeters squared. That's why we're squaring this centimeter unit, getting square centimeters. If it was a volume, we'd have r cubed because we're talking about cubic units. So let's go ahead and just do a couple of these examples together. Here we got, find the surface area of a sphere with the diameter of 4 meters. And so the first thing to think about is, well, that diameter is 4. The radius then is 2. I'm going to show my work here. 4 pi r squared is the formula. And I'm going to keep going here, plugging in my values as I go. This equation is already solved. I'm just simplifying what's over here on the right-hand side. So I'm going to do my order of operations, exponents first, 4 times pi times 4. And the commutative property of multiplication tells me I can multiply those numbers in whatever order I want. So I've got 4 pi, and this is in meters squared. That is my surface area. We can just leave that one in terms of pi. Next up, we've got a hemisphere with a radius of 6 meters. Now, the big thing here is there's 2 parts. If you're sitting here thinking, okay, well, the surface area formula should be just 2 pi r squared. Remember, that's just the outside of the sphere. That'd be half of the sphere. Write that down. The other part of this is there is a circle on the bottom. And so the circle is another pi r squared. That's from the circle. That circle wouldn't be visible on a full sphere because it's inside the sphere. Right? But on a hemisphere, when you cut it, you create that new surface that wouldn't have been there otherwise. So if we really want to, we can go ahead and put those 2 together. They are like terms. 2 pi r squareds and 1 pi r squared makes 3 pi r squared. But if you're going to write that down as the formula for the surface area of a hemisphere, you got to make sure that you realize that that's coming from 2 separate parts. Because eventually you're probably going to see a question that looks like this. It's a cylinder with a hemisphere on top of it. And if I do that, I only need the 2 pi r squared for that. For this one, I need the 2 pi r h from the lateral area of the surface of this, lateral area of the cylinder. And then I need my pi r squared for that bottom. So when we start doing, if we do some compound shapes, you just have to be careful there. So if I'm going to just break it down into do these two pieces. So if I do the actual hemisphere, 2 pi times 6 squared, well, 6 squared is 36, so 2 pi times 36, and 2 times 36 is what, 72 pi. And I do the circle, it's just pi times the radius squared, well, 6 squared is 36 pi, and then I can add them together, and that will give me what, 108 meters squared. There we go. And then the last one here, you're going to definitely see somewhere you're working backwards or using volume and surface area together. So this one tells you that the volume is 36 pi cubic centimeters, and we're finding the surface area. So we've got to find the radius first. So first off, let's use the volume formula, 4 pi r cubed, because it's volume, over 3. I'm going to plug in my 36 pi. And then we'll start doing some steps here. I'm going to multiply, try to do a different color. Multiply both sides by 3, which will cancel out that 3 and give me 108 pi equals 4 pi r cubed. Then I will divide both sides by 4 and by pi, 4 pi. That'll cancel out the pi's, so no more pi's to deal with. That'll cancel out these 4's, and 108 divided by 4 is 27, equals r to the third. Then I'm taking the cube root of r. Cube rooting is just the inverse operation to cubing. It's asking the question, what to the third power is 27? And 3 to the third power is 27. So r is 3. Then we'll go back and actually answer the question we want to answer, which is what is the surface area? 4 times pi times 3 squared. Do my exponent first. Remember, on this side, we were solving an equation. That's why I'm doing things to both sides. On this side, it is already solved for surface area. It says surface area equals, I'm just simplifying. This is not solving an equation. 36 pi centimeters squared, because this is area. Now, a big thing to kind of look at here, and this question just happened to have a volume and a surface area that came out to the same numerical value. Very, very important that you understand this. That does not mean in any way that the volume and surface area are the same. That'd be like saying that 4 gallons of milk is the same thing as 4 oranges. Just because the same numbers there does not mean that they are the same as each other. This is cubic centimeters, it is a volume. This is square centimeters, it is an area. And it's not a coincidence that those numbers are the same. It has to do with the fact that since the radius was 3 in this case, the divided by 3 and the extra times 3 up here just happen to cancel out. And you end up with the same number. But that will not happen for any other size sphere. So don't expect that to be happening. Okay, so your homework for today is page 567. You're doing 1 through 6. Here is 1 through 5, and I did not put 6 up here. So you're going to have to go and look at the book to get number 6. On number 2, feel free to give me a decimal answer, because trying to give me an exact answer just makes no sense. So decimal answer, include, put the pi right in there in your calculator and just give me the decimal approximation. There's no reason to leave that in exact terms. Okay, I will see you later.